Welcome to this module on data protection. In this module, we're going to talk about the various replication options we have with Microsoft Azure. So we'll talk about the various storage redundancy options like local redundant storage, zone redundant storage, geo redundant storage, and RA geo redundant storage. We'll also talk about the backup service offerings that Microsoft has with Recovery Services Vault and how you can utilize this to ensure that your backup is available. How would you implement your on-premise file and folder backups? Do we need some kind of an agent to be installed on the Windows server? Well, it's called as a Mars agent, which we'll talk about in some time. There are different recovery scenarios which we'll talk about, and thereby we'll understand the various Azure site recovery benefits we have. What level of data protection do we have at the virtual machine level? So that's where we'll get introduced to snapshots, Azure backups, and Azure Site Recovery. What are your workload protection needs? To end with, we'll take a look at the Azure to Azure architecture as to how the Recovery Services Vault can let you do that, and then the backup options available in the Recovery Services Vault. How do you implement virtual machine backups? How do you implement a virtual machine restore? There's a service offering within the Azure Resource Manager which is called as Azure Backup Server, and that uses something called as a Data Protection Manager, and today it's called as Microsoft Azure Backup Server, and in short MABS. We'll compare the various options we have for backup purposes, including the Mars agent and the Azure backup servers, and in what scenario would you be using that. Well, it's just not theory, but we'll take a look at things in action so that you get a better handle on these things. To end this chapter, we'll also go through the review questions for this chapter. Well, thanks for your time. Let's get started. If you have created an Azure storage account, you should be familiar with this wizard. One of the options that you have when creating an Azure storage account is replication. And there are numerous options you have here. The data in your Azure storage account is always replicated to ensure durability and high availability. Azure Storage Replication copies your data so that it is protected from planned and unplanned events. These events will range from transient hardware failures, network outages, power outages, massive natural disasters, and so on. You can choose to replicate your data within the same data center or across zonal data centers within the same region or even across regions. Replication ensures that your storage accounts meets the required service level agreements for storage even in the case of a failure. When you create a storage account, there are multiple replication schemes that are available for us, starting with local redundant storage, then the zone redundant storage, a geo redundant storage, then there is read access geo redundant storage, the geo zone redundant storage, and then finally read access geo zone redundant storage. The objective of this lesson is that you understand these replication schemes we have. In the upcoming lessons, you will learn about these replication schemes as we go through them one after another. Let's talk about local redundant storage, also called as LRS. LRS is a low-cost option for protecting your data from local hardware failures. If a data center level disaster occurs, for example, think about fire or flooding, and then you may be losing all the data. All the replicas may be lost or unrecoverable if you have chosen LRS. So LRS is most appropriate in the scenarios if your application stores data that can be easily reconstructed. If the data loss occurs, then you may opt for LRS. Some applications are restricted to replicating data only within a country due to data governance requirements. In that case, you may want to pick and choose LRS. LRS provides at least 9 and 11 nines durability of objects over a given year. LRS provides the object durability by replicating your data to another storage scale unit within that data center. A data center located in the region where you created your storage account will host that storage scale unit. A write request to an LRS storage account returns successfully only after the data is replicated to all the replicas. This is where you maintain 3 copies of your data. Each replica resides in a separate fault domain and upgrade domain within that storage scale unit. Think about a storage scale unit as a collection of racks of storage nodes. A fault domain is a group of nodes that represent a physical unit of failure. Think about fault domain as nodes belonging to the same physical rack. An upgrade domain is a group of nodes that are upgraded together during the process of a service upgrade or a rollout. The replicas will be spread across different upgrade domains and different fault domains within one storage scale unit. This architecture ensures your data is available if a hardware failure affects a single rack or when nodes are upgraded during a service upgrade. Like I told earlier, LRS is the lowest cost option, and this will offer least durability compared to other options we have here. This is where you are maintaining three copies of your data, and the strategy here is that your data is replicated three times within a single facility in a single region. With all this set of features, do you think that LRS is a good choice for your organization? Just keep in mind that the data will continue to reside in the same data center. Three copies will be maintained in the same data center. So if your application has the ability to reconstruct the data if the data loss ever happens, then you'll go for LRS. And also keep in mind about the data governance requirements. If you want to make sure that the data does not go out of your data center at all times and still have some form of redundancy within the data center, then again, LRS is the option. But then think about a scenario where you have a data center level disaster, probably a fire or a flooding happening. In that case, LRS will not be helpful at all because you then got to choose the other options like zone redundant storage and geo redundant storage. Let's go talk about them in the next lesson. The next option in the replication schemes is the zone redundant storage. The zone redundant storage, also called as ZRS, synchronously replicates your data across three storage clusters in a single region. Each storage cluster is physically separated from others and resides in its own availability zone. Each availability zone and the ZRS cluster within it is autonomous within separate utilities and networking capabilities. Storing your data in ZRS account ensures that you will be able to access and manage your data if a zone becomes unavailable. ZRS provides excellent performance and extremely low latency. There are a few things that you gotta know about ZRS, that ZRS is not available in all regions. You also gotta know that changing to ZRS from another data replication option requires the physical data movement from a single storage stamp to multiple stamps within a region. Also, ZRS may not protect your data against a regional disaster where multiple zones are permanently affected. Instead, ZRS offers resiliency for your data in case of unavailability. With ZRS, you are maintaining three copies of your data, but that data is replicated three times across two or multiple facilities, either within a single region or across two regions. ZRS is currently supported on general purpose V2 accounts, and ZRS is available for block blobs, non disk page blobs, files, tables, and queues. But what happens when a zone becomes unavailable? Well, when that happens, your data is still accessible for both read and write operations, even if a zone becomes unavailable. Microsoft recommends that you continue to follow the best practices for transient fault handling. These practices include implementing retry policies with exponential backoff. So when a zone is unavailable, Azure undertakes networking updates such as DNS repointing. These updates may affect your application if you are accessing your data before the updates have completed. ZRS may not protect your data against a regional disaster where multiple zones are permanently affected. Instead, ZRS offers resiliency for your data if it becomes temporarily available. For protection against regional disasters, Microsoft recommends that you go and use geo-redundant storage. So we'll use ZRS for scenarios that require strong consistency, strong durability, and high availability, even if an outage or natural disaster renders a zonal data center unavailability. To protect your data against a regional outage, you gotta use geo-redundant storage, and we'll talk about that in the next lesson. Let's now talk about the other two options in the replication schemes for the storage accounts. So that's GRS, Geo Redundant Storage, and Read Access, GRS. With the Geo Redundant Storage, you will have your data replicated to a secondary region, which is hundreds of miles away from the primary location of the source data. And for all those good reasons, GRS will cost you more money than LRS. But GRS provides a higher level of durability for your data, even if there is a regional outage. GRS is designed to provide at least 99.169 durability. So if your storage account has GRS enabled, then your data is durable even in the case of complete regional outage or a disaster in which the primary region is not recoverable. For a storage account with GRS or RAGRS enabled, all data is first replicated within the local redundant storage, and then an update is first committed to the primary location and then replicated using LRS. The update is then replicated asynchronously to a secondary region using GRS. When data is written to the secondary location, it is also replicated within that location using LRS. Both the primary and secondary regions manage replicas across separate fault domains and upgrade domains within a storage scale unit. The storage scale unit is the basic replication unit within the data center. Now, replication within the data center, as we know, is provided by LRS. So if you opt for GRS, you have two related options to choose from. So there is GRS that replicates your data in another data center in a secondary region, but that data is available to be read only if Microsoft initiates a failover from primary to secondary. And then there is RA, which is read access geo-redundant storage. And this also replicates your data to another data center in a secondary region and also provides you the option to read from the secondary region. So with RAGRS, you can read from the secondary regardless of whether Microsoft initiates a failover from primary to secondary. Well, there are a few terms we should be aware of as far as disaster recovery is concerned, the recovery time objective, and the recovery point objective. And we learned about these acronyms in AZ-900 certification, which is the fundamentals of Microsoft Azure. And from there, we know that recovery point objective is till what point you can get the data back up to. Whereas recovery time objective is how much time will you take to restore that data. So in GRS and RAGRS, the storage service, we know that it is asynchronously geo-replicating the data from primary to a secondary location. In the event the primary region becomes unavailable or goes down, you can perform an account failover to the secondary region. When you initiate a failover, recent changes that have not yet been geo-replicated may be lost. The number of minutes of potential data that's lost is recovery point objective. The recovery point objective indicates the point in time to which the data can be recovered. Azure Storage typically has RPO of less than 15 minutes, although there's currently no SLA on how long geo-replication takes. Talking about recovery time objective now. Just to reiterate, the recovery time objective is a measure of how long it takes to perform the failover and get the storage back online and get the business back up and running. The time to perform the failover includes several kind of actions. And that could be the time until the customer initiates the failover of the storage account from the primary to the secondary region. How about the time required by Azure to perform the failover by changing the primary DNS entries to point to the secondary region? So if you enable RAGRS and your primary endpoint for your blob service is, let's say, myaccount.blob.core.windows.net, then your secondary endpoint, which is myaccount-secondary.blob.core.windows.net, will take some time. The access keys for your storage account are the same for both the primary and secondary endpoints. In the next lesson, let's talk about the remaining two replication schemes, which is GZRS, which is Geo Zone Redundant Storage, and the read access part of RAGZRS. Let's now talk about the other two replication schemes, Geo Zone Redundant Storage or GZRS, and the other one which is Read Access GZRS. Now notice that both of them are in preview. Let's talk about the first one. Geo Zone Redundant Storage or GZRS combines the high availability of a zone redundant storage with protection from regional outages as provided by Geo Redundant Storage. Data in GZR's storage account is replicated across three availability zones in the primary region and also replicated to a secondary geographic region for protection from regional disasters. Each Azure region is paired with another region within the same geography, together making a regional pair. Now, with a GZRS storage account, you can continue to read and write data if an availability zone becomes unavailable or is unrecoverable. Additionally, your data is also durable in the case of a complete regional outage or a disaster in which the primary region is not recoverable. GZRS is designed to provide at least 99.169 durability of objects over a given year. GZRS also offers the same scalability targets as LRS, ZRS, GRS, or even RAGRS. You can optionally enable read access to the data in the secondary region with the second option, which is RAGZRS. So if your applications needs to be able to read the data in the event of a disaster in the primary region, you will go for the second option, which is RAGZRS. Microsoft recommends using GZRS for applications requiring consistency, durability, high availability, excellent performance, and resilience for disaster recovery. For the additional security of read access to the secondary region in the event of a regional disaster, you would enable RAGZRS for your storage account. Now, both of these are in preview at the time of this recording. Just to summarize, if you're choosing GZRS, it means that data is replicated across three availability zones in the primary region and replicated to a secondary geographic region for protection from regional disasters. The second option is enabling read access of the data in the secondary region with read access geo zone redundant storage. Now, with multiple options that we have, it's important to compare all of these replication strategies and understand in what scenario would you use a particular replication scheme. In the next lesson, you will have a quick overview of the scope of durability and availability that each replication strategy will help you given a type of event or impact that happens on a particular data center or in case of a region-wide outage. In this lesson, let's talk about Azure Backups and the key benefits that Azure Backups provide. Azure Backup is an Azure-based service you can use to backup and restore your data in the Microsoft Cloud. Azure Backup replaces your existing on-premises or off-site backup solution with a cloud-based solution that is reliable, secure, and cost competitive. Azure Backup offers multiple components that you download and deploy on the appropriate systems or in the cloud. The component or agent that you deploy depends on what you want to protect. All Azure Backup components can be used to back up data to a recovery services vault in Azure. So no matter whether you're protecting data on your premise or in the cloud, you got to have some kind of an agent and that will then push that backup data to recovery services vault in Azure. Let's talk about the key benefits of using Azure Backup. Azure Backup offers a simple solution for backing up your on premise resources to the cloud. You can get short term and long term backups without the need to deploy complex on premise backup solutions. Azure Backup provides independent and isolated backups to guard against accidental destruction of original data. Backups are stored in Recovery Services Vault with built-in management of recovery points. Configuration and scalability is simple. Backups are optimized and you can easily store as needed. Azure Backups does not limit the amount of inbound or outbound data you transfer or even charge for the data that is transferred. Outbound data refers to the data transferred from Recovery Services Vault during the restore operation. If you perform an offline initial backup using a service called as Azure Import Export Service, that is done to import large amounts of data, then there is a cost associated with the inbound data. You will keep your data secure because data encryption allows for securing the transmission and storage of your data in the public cloud. You store the encryption passphrase locally and it is never transmitted or stored in Azure. If it is necessary to restore any of the data, only you have the encryption passphrase or the key. You'll always get app consistent backups. An application consistent backup means a recovery point has all the required data to restore the backup copy. Azure Backup provides application consistent backups, which ensure additional fixes are not required to restore the data. Restoring app consistent data reduces the restoration time. This will allow you to quickly return to a returning state. Think about how do you retain short and long-term data. You can use Recovery Services Vault for short-term and long-term data retention. Azure does not limit the length of time data that can remain in the Recovery Services Vault. You can keep it as long as you like. Azure Backup has a limit of 9999 recovery points per protected instance. Azure Storage Management. Hybrid environments often require heterogeneous storage, some on premises and probably something in the cloud. With Azure Backup, there is no cost for using on premise storage devices. Azure Backup automatically allocates and manages backup storage, and it uses a pay as you use model so that you only pay for the storage you consume. There are multiple storage options with Azure Backup. With Azure Backup, you got two types of replication to keep your storage data highly available. There's local redundant storage and then GRS, which is geo redundant storage. We know that with LRS, your data will be 3 times copied to the local storage scale unit in that data center. All copies of the data exist within the same region. LRS is the low-cost option for protecting your data from local hardware failures. Whereas GRS is the default and recommended replication option, your GRS replicates your data to a secondary region, which is hundreds of miles away from the primary location of the source data. And for all those good reasons, GRS will cost you more than LRS. But GRS provides a higher level of durability for your data, even if there is a regional outage. So what are some of the reasons your organization might choose Azure Backup? In the next lesson, let's understand the Recovery Service Vault backup options. The Recovery Services Vault is a storage entity in Azure that houses your backup data. The data is typically copies of your data or configuration information for virtual machines, workloads, servers, or even workstations. You can use Recovery Services Vault to hold backup data for various Azure services, such as infrastructure as a service virtual machines, could be Linux or Windows, and even Azure SQL databases. Recovery Service Vault supports System Center Data Protection Manager, Windows Server, Azure Backup Server, and several other backup solutions. Recovery Services Vaults makes it easy to organize your backup data while minimizing your management overhead. The Recovery Services Vault can also be used to back up on-premises files and folders. It's important to know that within your Azure subscription, you can create up to 25 recovery services vaults per region. There will be several backup choices for the virtual machines, which we'll be covering up in the upcoming lessons. Let's go ahead and create a recovery services vault in this lesson. And in the upcoming lessons, let's go ahead and see how you can configure it. Now at this point, I've got the Azure portal open. I will select the subscription, select my resource group, select the vault name, call it as Enterprise Backup, and the region I will leave it as East US, and then click on Review and Create. And now I'll click on Create. It may take up to several minutes for the Recovery Services Vault to be created. We can monitor the notification area on the upper right hand area of the portal. And once the vault is created, it will appear in the list of Recovery Services Vault. I'll continue from here in the next lesson where we'll see how you can configure the backups for the new instance. So there you go, the deployment is complete. Let's click on Go to Resource. Okay, so that's the Enterprise Backup Recovery Services Vault we got. And as we scroll down to the bottom, we got an option to backup. So that's the Getting Started Guide for backups. And there are two places where you should be focusing on in the Recovery Services Vault for backups. One is the backups under the Getting Started section, and the second one is Protected Items, and there you got backup items as well. Now, if you click on Backup under Getting Started, it may be asking for where your workloads are running. What do you want to back up? So if your workloads are running on Azure, then you got to select Azure. But as you see, they got other options as well, like Azure Stack and on-premise. Azure Stack is a service offering from Azure that will let you build private clouds. So if you have used Azure Stack to build a private cloud, then this might be the right bet for you. But if you got workloads running on your premise, probably on a VMware environment or Hyper-V, then you got to select on premises. The next option we have is what do you want to backup? What kind of data do you want to backup? Are they files and folders, Hyper-V virtual machines, VMware virtual machines, and they got lots of other options right here. In this case, let's go ahead and select Azure here under where your workloads are running. And then you will have the options to either select a virtual machine, an Azure file share, which is currently in preview, and then an SQL server in an Azure virtual machine. Now, the first option and the second option are infrastructure as a service, whereas this one is looking at your storage account. So if you're using file shares in your storage account, you will be choosing that one. But keep in mind that it's not in production yet, it is in preview. Now, when I click on Backup after selecting Azure File Share, it should be going and looking at my storage accounts. Do I have any storage accounts? If yes, it's going to then show up on this list. I have to click on it and then move on to the next steps where I need to select the file share in that storage account. But one thing that I want to show you is what happens if you select on-premise. Do I need an agent? Well, let's see. Now I'll go ahead and select on-premises here and then choose Files and Folders under this section and then click on Prepare Infrastructure. This is where I need to download the Mars agent. Microsoft Recovery Services agent is nothing but Mars. So I'll click on that and then it will prompt me for a download. And there you go. It's there in my download manager, downloading things for me. But what's also important is the vault credentials. And I can download the vault credentials by just checking this and then clicking on download. So when you install the Mars agent on your machine, it will then ask for the vault credentials which you got to select. And then you will schedule the backup. And once the backups are scheduled, you can backup jobs page to monitor the backups. And we'll take a look at that in a minute. But the objective is to tell you that this is where you can download the Mars agent from. And you also need to have the vault credentials in place. By default, the Mars agent is downloaded in your downloads folder. So when the installer completes, a pop-up asking if you want to run the installer or open the folder may pop up. So you don't need to install the agent yet because you may want to take the agent to the virtual machine or the physical server on your premise and then install it. And during the installation, like I said, you may need the vault credentials to be mapped to the Mars agent. One thing to keep in mind is that if your administrator in your organization has already downloaded the Mars agent and kept it somewhere on the file server, make sure that that's the latest one. You need to go to the Microsoft website, identify what is the latest Mars agent, and then check if the one in the file server is the right one. At this point, I'll go to the virtual machine section and create a virtual machine, and then once the virtual machine is created, I will install the Mars agent on that virtual machine. I'm just simulating an on-premise infrastructure because I do not have an on-premise infrastructure. So I'm just simulating an environment where I will have the Mars agent installed on the virtual machine in Azure. Well, it doesn't matter where the virtual machine is, the Mars agent still would be effective to take your backup securely and effectively. But just for demonstration purposes, I will have the VM created in some time and then connect to it. Let's continue with the remainder of this installation in the next lesson. Okay, that's our recovery services vault. And then if I look into the backup section under the essentials, you will see if any backups have occurred in the last 24 hours, what is the backup pre-check status for all your Azure virtual machines, any backup items that have happened, basically the statistics of your Azure backup. For now, to demonstrate the Azure backup, I've created a virtual machine in Azure, just simulating an environment of an on-premise infrastructure. So I've already copied the Mars agent that we downloaded earlier and I'm ready to install it. So I'm going to double click on it and then let it do its job like extracting files and whatever it got to do. So this installer here provides a series of messages as it extracts, installs and registers the recovery services agent. Let's walk through this. Now this is the default location, C program files, and I'm going to keep it like that. If I have any proxy settings on my enterprise, you can select that and then click next. Do you want to opt in for any Microsoft updates? At this point, I'll just select I do not want to use Microsoft updates and then move on further. And finally, click on install. This will take a minute to get that product installed. Okay, looks like that's installed. So let's proceed to register our Azure backup in the Recovery Services Vault in Azure. So I'm going to click on proceed to registration. And this is where I got to point my vault credentials. So I'll browse to my desktop. That's where my file is. Okay, and then click on open, next, and then finish through this wizard as well. One thing to keep in mind that you got to have a passphrase. This is required for you to register to the Azure Recovery Services Vault. You also have the option to generate a passphrase for you and then save it to a secure location. We'll keep it under the C drive, create a new folder if that's required, but make sure that it is saved somewhere. Okay, so I've named the folder as passphrase. I'll click on OK. That's where my credentials will get stored and finish. That's it, you're done. The agent is now installed on your machine. It would also be registered in the vault. So you're now ready to configure and schedule your backups. I'll wait for this registration to complete. And once this is done, we'll launch the Microsoft Azure Recovery Services agent and then go through the steps to configure and schedule your backup. Looks like that's done. So I'll click on close and then launch the Microsoft Azure backup. And now this is where you gotta go and schedule the backups. So when you click on schedule backup, you will have the options to select whether you want a differential backup or a full backup or a system state backup of the machine. Okay, so let's go through that. Now you can select the items that you want to back up, click on add items, and then just for demonstration purposes, I'll select the passphrase folder. It's just for demonstration, but then in real time, you will be selecting probably the file server data, your intellectual property that you want to take a backup of, things like that. So click on OK. Keep in mind that you also have the option to exclude something from the backups. Well, you can add an exclusion and say, hey, I don't want to take a backup of a particular file or a particular folder. You can do that. So I will ignore that for a minute and then click next. Now, when do you want to schedule your backup? Is it daily or weekly? If it is daily, at what time do you want to take a backup? You're allowed to take a backup of maximum 3 times in a day. So you can select 3 different schedules from these drop-down menus. At this point, I'll leave it as 9 p.m. for the day and click on next. Then I've got the retention policies. What should be the retention policies? So you can now specify the retention policy for the backup copy of your files and folders. So you got weekly retention, monthly retention, and yearly retention as well. Keep in mind that you got the modify options. These are not static, but you can definitely modify these values. I'll leave this as default and click on next. Now you got few important options here. How do you want to back up your data? Should they be copied automatically over the internet? Or do you want to create a staging location first and then have the backup done here? And then at a particular time, it can then be copied over to a storage account and then to a recovery services vault. So if you got bandwidth issues or if this backup is happening at production hours and you do not want to choke the network traffic in your organization, well then offline backup will be best for you. In this case, I will just choose the first option, which is automatically take the backup over the network, and then click next. Finally, you get a summary of all the options that you have chosen during this wizard, right? So if you're happy with this, satisfied with these values that you've selected, all we got to do is click on finish. There you go, that's done. So all you got to do is close this wizard. Since you have scheduled the backup now, the backup will be triggered at 9 p.m. But then if you want to trigger a backup right now, well, there's an option here to back it up right now. So click on that and walk you through the wizard. Well, you have the options to choose whether you want to back up files and folders or the system state. I'll leave this option as files and folders. Click on next. And then you can specify the date till which you want to retain the backup. Yeah, this is also a retention period that is specified for the backup that you are triggering right now. Well, I'll leave the date as it is and click on next. You get a summary of that and then I'll click on backup. It may take some time for the backup to happen depending on the amount of data that you have chosen because it then has to get transferred to our internet-based cloud backup as well. Okay, so looks like that is completed. I'll click on close to get rid of this. And now let's navigate to the Azure portal to see if we have this backup in our recovery services vault. Okay, so I'll minimize this, and then if I navigate to my recovery services vault, let me collapse this so we get a better view. What you see is there is one backup item now. You click on it further, then you will see that the backup is happening from an Azure backup agent. So for all your on-premise workstations or on-premise servers, you will have the Azure backup agent installed, and then you will see the number of agents installed on each server. If it is an Azure virtual machine, you will see that here. But you may be asking, now this virtual machine on which we have installed the Mars agent is an Azure virtual machine. Why don't we see a number here? Well, that is because we installed the agent. Whenever you install an agent, you will see the number 1. Usually you install the Mars agent on an on-premise infrastructure or probably in a different cloud. In this case, just to simulate an environment, we created a virtual machine in Azure and then installed the Mars agent. Let's go back to the server now and then try to restore a particular file. So let's say my file or a folder is getting deleted from the C drive. So I will navigate to the C drive and then simulate as if the file is getting accidentally deleted. In fact, I'll go ahead and delete the whole folder from here and see how we can restore it from Azure. Now that the data is in Azure, but then the agent is installed on the server, I can restore it or recover it from the Microsoft Azure backup agent installed on the server. To recover it, I just got to click on the recover data option and then walk through the wizard. That's all. So that's how simple it is. Okay, so that's the recover data wizard, and you got the options to restore it on this server or on another server. I'll click on next now. Recovery mode. Do you want individual files and folders to be restored? Is it a volume restore or a system state restore? The kind of backup that we have taken is an individual files and folders, so I will leave it as it is. But then in your case, it may be a different ballgame altogether. So you may want to choose a volume or a system state depending on what kind of backup you have chosen, right? So now I'll click on next. Okay, now where do you want to restore it? Okay, now it is looking around the C drive and then giving me the restore points. Now it looks like the backup was taken on 23rd. I'll leave it as it is and then say mount it. Okay, I got the recovery volume as an E drive. So I have the option to either browse through it or unmount it. Well, I don't want to unmount it right now because I want to go to that E drive and see how that looks. So I'll click on browse and then click on the Explorer. And there you go, I've got a new drive here with the folder that was backed up. Now I can double click on it and I've got all my files that were there inside the folder. Now I can copy this and then paste it into the original location which got accidentally deleted. Now in this lesson we looked at how you can install the Mars agent on your server and then schedule the backups initiate the backups, and also recover the files using the Microsoft Azure Backup Agent, also called as an Mars agent. In the upcoming lessons, let's take a look at Azure Site Recovery scenarios. Let's talk about Azure Site Recovery. You can use Azure Site Recovery to replicate an on-premise, physical, or virtual machines running Windows or Linux. Azure Site Recovery includes support for both Hyper-V and VMware virtual machines. You can replicate data from your on-premise data center to Azure or to a secondary site. Orchestration is built in with Azure Site Recovery, which means that the management of replication, failover, and recovery is included. For example, should a virtual machine or a service fail in your data center, you can use Azure Site Recovery to fail over to the replicated resource in Azure or to a secondary site. Azure Site Recovery works with the following three scenarios. First one is Hyper-V virtual machine replication, then there is VMware virtual machine replication, and then physical Windows or Linux machines. When Virtual Machine Manager is used to manage Hyper-V virtual machines, you can use Azure Site Recovery to replicate them to Azure or to a secondary data center. If you do not use VMM to manage your virtual machines, you can use Azure Site Recovery to replicate them to Azure only. With VMware Virtual Machine Replication, with this you can perform the replication of virtual machines by VMware to a secondary site that is also running VMware. You can also replicate to Azure with this method. And the last option is where you got physical Windows and Linux machines. So now you can replicate physical machines running either Windows or Linux to a secondary site or to Azure. Let's talk about the various benefits that you're going to get with Azure Site Recovery. A migration to the cloud can result in significant business benefits that you're aware of already. And there are certain reasons to use Azure Site Recovery. First one being eliminate the need for disaster recovery sites. Your environment can be protected by automating the replication of virtual machines based on policies that you set and control. Site recovery is heterogeneous and can protect Hyper-V, VMware, and physical servers. You can reduce the infrastructure costs by using Azure as a secondary site for conducting business during outages. You can also eliminate the data center costs altogether by moving to Azure and setting up disaster recovery between Azure regions. You can pre-assess network, storage, and compute resources needed to replicate the applications from on-premise to Azure, and then you pay only for compute and storage resources needed to run the apps in Azure during outages. You can automatically replicate to Azure. You can automate the orderly recovery of services in the event of a site outage at a primary data center. You can automate the order in which the recovery of services needs to happen in the event a site outage at a primary data center occurs. You can protect complex workloads like SQL servers, SharePoint, SAP, and Oracle. You can also extend and boost the capacity, like applications can be migrated to Azure with just a few clicks, or burst to Azure temporarily when you encounter a surge in demand. It's important to do a continuous health monitoring. The site recovery will monitor the state of your protected instances continuously and remotely from Azure. So when you're replicating between two sites you control, your virtual machine data and replication remains on your networks. All communication with Azure is encrypted. Protecting your data in the virtual machines is so critical, and you can protect your data by taking backups at regular intervals. There are several backup options that Azure provides depending on your use case. You can take snapshots, Azure backups, or even use Azure Site Recovery. For backing up Azure virtual machines running production workloads, we'll use Azure Backup. Azure Backup supports app-consistent backups for both Windows and Linux virtual machines. Azure Backup creates recovery points that are stored in geo-redundant recovery vaults. When you restore from a recovery point, you can restore the whole VM or just specific files. Azure Site Recovery will protect your virtual machines from a major disaster scenario when a whole region experiences an outage due to a major natural disaster or a widespread service interruption. You can configure Azure Site Recovery for your virtual machines so that you can recover your application with a single click in a matter of minutes. You can replicate to an Azure region of your choice. Snapshots. In development and test environments, snapshots provide a quick and simple option for backing up virtual machines that use managed disks. A managed disk snapshot is a read only full copy of a managed disk that is stored as a standard managed disk by default. With snapshots, you can back up your managed disk at any point in time. These snapshots exist independent of the source disk and can be used to create new managed disks. They are built based on the used size. For example, if you create a snapshot of a managed disk with a provision capacity of, let's say, 64 gigs, and actual data size is 10 gigs, the snapshot is built only for the used data of 10 gigs. There's another concept called as images. Managed disks also support creating a managed custom image. You can create an image from your custom virtual hard drive in a storage account or directly from a generalized sys-prepped virtual machine. The process captures a single image, and that image contains all the managed disks associated with the virtual machine, including the operating system and the data disk. The managed custom image enables creating hundreds of virtual machines using your custom image without the need to copy or manage any storage accounts. It's important to understand the difference between image and a snapshot. Let's go ahead and learn about it in the next lesson. It's important to understand the difference between images and snapshots. These are totally different concepts. Although they are related to the disks, they mean totally different things and solve a different purpose. In Azure, with managed disks, you can take an image of a generalized virtual machine that has been deallocated. The image includes all of the disks attached to the virtual machine, and you can then use this image to create a new virtual machine, and that would include all the disks. That means the content of the virtual machine from where the image was taken may have certain applications, probably antivirus, maybe you have done certain server hardening procedures, maybe disabling user account control, disabling firewall, making certain registry modifications, etc. And then you may want to think about deploying multiple virtual machines out of that VM. But before you do that, you will take the image of the virtual machine and then start deploying virtual machines from that image. This saves a lot of time because you then do not have to install those applications again, do the server hardening procedures again, and all the changes in the registry that you did. So that's the whole point of creating an image, which is basically creating multiple virtual machines out of the image. A snapshot is a copy of a disk at that point in time. It applies only to one disk. If you have a virtual machine that has one disk, you can then take a snapshot of it and then you can create the virtual machine from that snapshot. Snapshots are used to perform point in time restores. That means just in case if your virtual machine ever gets corrupted or goes into a blank state or maybe blue screen of death or something, you can then go ahead and take the snapshot of the virtual machine. A snapshot does not have awareness of any disk except the one it contains. And that makes it problematic to use in scenarios that require the coordination of multiple disks, such as striping. Snapshots would not be able to coordinate with each other, and this is currently not supported. So keep in mind that images are used to create multiple virtual machines out of the image, whereas snapshots are used to perform point in time restores just in case your virtual machine goes bad, or some of the files get corrupted, the operating system gets corrupted maybe, or some of the reasons you may want to go back to a date when the virtual machine was healthy, so you will then restore from the snapshot. Let's now talk about Microsoft disaster recovery solution called Azure Site Recovery. In this lesson, we'll focus on how you can get your primary site up and running in the event of a disaster. The original intent of Azure Site Recovery is to provide site recovery, although you can definitely use it for migrations. Site recovery has automated replication process from primary to secondary, and you can configure that. Azure Site Recovery is backed up by something called as application consistent backups, and this is also based on VSS or pre or post script frameworks. We can replicate in two ways using Azure Site Recovery. You can either replicate from Azure to Azure or from on-premise to Azure. So you may have a lot of workloads on your premise and you want to use Azure Site Recovery to keep a secondary site in Azure. Maybe using ASR for on-premise environments, you can have Azure as primary or Hyper-V as primary or even VMware. You can get support for both Windows and Linux environments. But keep in mind that there are certain limitations to ASR. For example, if you want to migrate from physical servers or from VMware, then there are certain limitations. Also, not all Linux distributions are supported. Let's take a look at few key components of site recovery and let's understand few points from here. So there's a source environment from where the data needs to go and the target environment where the data needs to be replicated. Then there is a replication policy. Replication policy is about configuring how and when you would like to replicate. Before replication is actually committed to the target environment, it needs to be cached on a cached storage account. Another key component is the recovery plan. Recovery plan is, let's say, in the event of a disaster, how do you plan to turn on the new environment? Do you like to start up the environment in a certain order or in groups? Are there any manual steps that you'd like to do? Or do you want to run any scripts automatically when a failover happens? Now let's take a look at ASR in the Azure portal. So here's the three-tier design. There's a web server, an SQL server, an app server. All of these are running in East US. Now, if you'd like to use the capabilities of Azure Site Recovery to ensure that the customers never get impacted if the East US site goes down, we would like to go ahead and utilize the ASR feature. So let's go ahead and create an site recovery plan. Just type site there and select Recovery Services Vault. You've got to create a Recovery Services Vault first, and then I'll just fill it up quickly. Vault name, and I will host this in the West US location because my original resources, all of these are in East US. Say West US here and click on review and create it. Looks like the vault is created, so I'll click on it and see how we can replicate from East US to West US. So if you navigate to the Getting Started section under Site Recovery, you will have the replication options. Well, the first option is to prepare the infrastructure. Earlier, I did mention that we can move from on-premise to Azure or from Azure to Azure. Depending on how your configuration is set, you might want to select these. So these steps will help you prepare the infrastructure accordingly based on VMware setup, Hyper-V, or from Azure. In case your virtual machines are located on-premise, you might want to choose how you plan to replicate. Is it to Azure or to the recovery site? You can just select no if recovery is your objective. You also have the options to select Hyper-V here. How do you want to manage the Hyper-V hosts? And if you're using an SCVMM. Well, like I said, this is the preparation phase, but in our case, we got all the virtual machines in Azure, so we can directly skip to step one here, which is replicating the application. You can either click on the replicate option or under the overview, you got this replicate button, which will take us to the same place. Now this is where we select the source. In my case, the source is in East US, so I will select the East US in the drop-down menu and then select my resource group, which is prod-rg, and then click on OK. It will now detect all the virtual machines in that resource group, so I can select what I want to replicate. In this case, I will just choose to replicate a web server, and then I'll show you how you can add the rest of them to an application group. So click on OK, let that validation happen. Now on the top, you see the target location. We have all our resources in East US, and now it asks us where would you like your target location to be. These regions that you see are the supported regions that we have as on today. There are a few important things to notice here that you can customize the target resource group, the storage account, virtual network, and disks. Like I said, there is a new site that's being created, a totally new replica or a copy of East US. And to create the replica of the virtual machines, it needs to have some kind of a virtual network, a storage account, and then a resource group as well in the target region. If these naming standards do not follow as per your naming conventions in your company, you can go ahead and click on customize and modify these values here. For now, I'll just close this and see what replication policy is. Well, you can customize the replication policy. It says that the replication is going to happen every 24 hours. Well, let's go ahead and see what this app consistent snapshot frequency is. This is the RPO. If you have 4 here, that means in worst case scenario, you would lose 4 hours of data. How frequently would you like to have the app consistent snapshots done? App consistency can actually cause certain performance degradation issues. So if you keep it at 1, that means that the snapshots will be taken every 1 hour, and this will hit the performance of your application. We always say that the lower the RPO, better it is, but at the same time, we need to make sure that these values are not affecting the performance of your application. Then there is recovery point retention. What we are saying is that if we set this number to, let's say, 100, you will notice that there's an error message because the maximum value that you can go up to is 72. So let's say you have the number 72 here. It means that the backup is kept for 72 hours. Technically, this 72 hours is not sufficient. So when you're architecting solutions, ensure that you have low RPO and low RTO in picture to ensure that if you ever lose data, you lose minimal data. Then there is multi-VM consistency. In this example, we're using three-tier model where you got a web server, application, and a database. And you want to make sure that each of the VMs are backed up at the same time. So if the applications are dependent on each other, then this feature really helps. So what we are saying is that applications are grouped together, so they will be backed up together. They will have a crash consistent recovery point, and they will have an app consistent recovery point as well. In this case, I will group them and create a new group, call it business tier, and add my virtual machine to it. Let's click OK, and then click on create target resources. It will take a while to get this done, so I'll pause the video and get connected once it is ready. It took a while to get that sorted out, but then now it's ready. Let's click on enable replication. This replication from source to destination will take some more time because it has to create the entire set of resources in the West Coast. So we might have to go through creation of the resource group, storage account, virtual machines, etc. So I'll pause the lesson again and then we'll get connected once it is ready. Okay, the replication is complete. So now let's go ahead and see the features and what we can configure and how we can control the recovery plans. So I'll scroll down to the bottom and then look at protected items. Under that, once you click on replicated items, you will see the virtual machine that you are replicating from East US to West US. You can click on it further and it looks like there's a warning that means the replication is not 100% complete. But then once you click on it, you will be able to see the status. Now there's a warning here, but then this is more advanced panel here which will let you view the status of your data. The blue little dots are still dotted lines. That means the replication is still occurring. If you recall from this lesson, I was talking about the key components of site recovery, which is the source, East US, the target, which is the destination, West US. You will also have the cached storage, which will act as an intermediary before it gets committed to the destination or the target. What you can run is a failover. There's a test failover that you can also do. And at some point in time, if you would like to disable the replication, that option is also here. Let's go ahead and look at another key component, which is recovery plans. If you click on recovery plan, you're ready to create a recovery plan. So I'll give it a name. Let's call it plan 1. And this is for my East US site. And what kind of deployment model would you like to choose? I'll select Resource Manager. Classic will not be used anymore. It's going to be deprecated. So I'll select Resource Manager and then select the items that I want to keep as part of my recovery plan. What you will see is that there's a business tier. Yeah, I can select it and say OK, and then OK to that as well. Now my recovery plan is being created. What is it that you can do here? We discussed about recovery plans earlier when I was talking about the key components. So one is a source, other is a target, you got a storage account, and another one is the recovery plan. So in the event of a disaster, how do you plan to turn on the new environment is controlled by this recovery plan. Would you like to start up the servers in a particular order, or are there any manual steps that needs to be done, or do you need to run those scripts automatically? Well, that's what you got here. Okay, now that I'm in the plan here, let's go look at these options. Now, if you click on customize, there are interesting options that you will see is that once you expand on it and then click on these three little dots, which brings up the context menu, and then select the pre-action and post-action. This is what I was referring to. So you can add a script, a manual script or any kind of actions that you may want to take when the recovery actually happens. You can also link it up to your Azure automation account. At this time, I do not have an automation account, and that's why it's all grayed out, but then you can write a manual action if you'd like to do so. The script that's in place here, should that be executed during a testing process or the actual failover? These are interesting options that you can have here. But remember, we've got three servers in this tier and we are protecting just one server. So we've got just the web server in this group, but how do we make sure that all the three servers, SQL and the app server, are also backed up together? If you remember the multi-VM consistency concept, where we would like to have all the VMs being backed up together because they are all dependent on each other. So that's where the multi-VM consistency helps. So let's see how we can add it together. So for me to add those two virtual machines as well, the application and the SQL server, I need to go ahead and replicate them first. So I'll click on the replicate button and go through the same process. Yep, source location is east US, leave this as same thing, click on OK, and this time I will select both of these virtual machines, click on OK. But here I will choose to customize the replication policy. So I'll click on that, and then under multi-VM consistency, I'll select yes. And the replication group I'll choose as use existing, because I don't want to create a new group because we already have a group with the name business tier. Now in this tier, just one server exists, which is web server, and I would like to add app server and SQLDB together so they will have the same set of policies. Now I'll click on create target resources and then finally enable replication as well. And this replication of VM will take some time. So I'll pause the lesson and then connect once it is ready. Okay, looks like the replication of the two other virtual machines, the app server and the database server, is complete. Let's go check in the replicated items. Now under business tier, which was the name of the replicated group, if I expand this, I've got all the three servers here. Although they are in the group, but then the replication has not completed yet because of the size of the virtual machine and it will take some time. The recovery plans out here is really a powerful tool within the Azure Site Recovery. In the event of the disaster, you can configure it in such a way that you can recover with minimal loss. There are certain considerations that we must look into. One is that the oldest recovery point you can have is up to 72 hours. The data between the target and the source is constantly replicating, so there may be certain performance impact on your applications. Just to wrap up this module, what we learned here is the recovery time objective and the recovery point objective can be configured for the replicated items. Azure Site Recovery helps us to create a secondary site in the event of a failure, so you will have the secondary site ready just in case things go wrong. The key components of Azure Site Recovery are the source environment and the target environment. What we configure is the replication policies, so you can set the application consistency levels, multi-VM consistency, and also recovery point retention. What you'll also need is a storage account, which acts as a temporary storage between the primary site and the target site.